Now the track design starts with the drive sprocket. So here's a cross section of the drive wheel. There's the profile of it, and you can see I got a pretty decent groove for the center guide teeth, but I need to create a corner here so that the guide teeth stays centered in there. So I got to wrap a piece of steel around the outside of the rim to create that narrower gap, and then the width of the wheel is going to determine where these are the sprocket teeth, so that's going to determine where I need a gap in my track belt. And then the diameter is 8 7/8 outside diameter wheel, so that's going to determine my pitch. I took that and divided it by 12, so I got 30 degrees in between each sprocket tooth. And what these teeth are here, up here I simulated how the track is going to move as it unwraps and wraps onto the sprocket, and you can see it forms kind of a curve. And in order to have a little bit of room for error, I want the curve of the sprocket tooth to have a shorter radius than the curve that the track is moving, so that it doesn't hit the top of the tooth as it's coming around. So what I ended up with is I took a 1-inch diameter steel tube that's an 1/8 inch wall thickness and cut it into quarters. So I got this piece here, which is a quarter of the tube. I stacked 2 of those together to make the sprocket tooth, and then I'll do some testing to figure out exactly what pitch works best there. I learned from the Sherman that the belt is hard to do in a CAD program. It's hard to predict what this pitch is that you're going to actually need for it to work right, because the belt doesn't exactly move like a hinge. So I'll show that up next. Okay, to make these drive sprockets, this is a good groove for the center guides to fit, but I need something to make contact with it a little closer to center it. So I got these 2 strips of steel. I'm going to space them exactly the spacing I need to get between for the track guides to go between. I'm going to tack it on there and then put it in my shop press and roll it, tack it, roll it, tack it, and go all the way around until I got those 2 strips welded on, and then I'll start welding the teeth on. Let's see how this goes. Okay, I got one spot weld there, and I'll just press it, and then I'll add another tack here and there, and then roll it a little bit, and then tack it as we go, and cut off the excess when I'm done. Hopefully this makes it round enough, but I mean, it's a tank, it's not a Cadillac. Okay, here's how I'm going to make the sprocket teeth. This is a 1-inch OD 1/8 inch wall steel tube, and it's DOM, so it doesn't have a groove on the inside or a welding seam. And I scored a line on it every 1/4 of the way around the tube, and on 2 opposite sides I cut a groove about halfway through the thickness there, and then again on this side. And on the other scored lines, I'm going to cut it with my plasma torch. So I'll have 2 semicircle pieces with a scored groove in the middle, and then I'll put it on my chop saw and cut off a piece every 1/4 inch, and then I'll partially fold those together to make it a tooth shape. Okay, here's the tubes after splitting them in half. Okay, there's my 2 drive sprockets. 12 teeth. And all right, now I need to build a section of track and test that I've got the track pitch right. Well, if you watched my Stube build, this is going to look really similar. This is how I assembled the track. I had to make a few changes to this track assembly jig for the Hellcat tracks are a little different, but basically here's how it works. I've got a pocket in here that matches the angle and dimensions of these center guide teeth. It drops right in there. Then I've got these guides to line the belt up, and this track link lines up with this stop to get my track pitch exactly correct. So I'll close that and then pull that tight against the stop, drop in my next link. 2 screws go through the belt and into the track guide on the other side. There we go. already started here. This is my drive sprocket. Lines right up. So now I've just got about, I think it's 70 or so links per side, so about 140 links to put together. Here's a little test of my sprocket and the pitch. Don't you love that sound?
Well, after building one complete track, I bench tested it, you can see here, and about every 30 or 40 teeth, it would climb up onto the top of the tooth and skip a link. So my pitch was a little bit off. I did a number of measurements and it was off by 0.025 inches. So I disassembled the track and reassembled it with a 0.025 inch additional pitch added to the track length. So then I tested it again and worked great. Went all the way around the whole track several times and never saw any skipping, or it just worked real smooth after that point. So getting that track pitch is really, really critical and has to be precise.
Getting ready to fix the tracks to the tank for the first time. This track design, here they are ready to go. You can see it's actually 3 belts in order to create a gap for the sprocket teeth. Will go in this hole, and so the middle belt is going to take all of the tension for the driving force. The outer belt is really just so that the road wheels will span that gap. So the road wheels are run here, and that gives it an even surface for the road wheels to run on both sides. Otherwise, this outer belt isn't really doing much as far as carrying any load. So that was my idea for the design. And I didn't make these where I use like a master link to disconnect the track and put it on. I'm gonna just take off the outer row of wheels and put the track on, and then put the outer row of wheels back on, because breaking the track and then reconnecting it while there's tension on it is really difficult. So I think this is gonna be an easier way to go. Okay, tracks are on. Time for a test drive. Well, that first drive was a huge success. I had one problem, which is my own fault. There's a pin here to hold the wheel on. There's another one inside the hole to hold the suspension arm in the hole. And I forgot to put the pin in on these 2 front idler wheels. So this wheel started to walk out, and so we had to stop. And so I fixed that, and while I had it apart, I increased the tension on this front wheel, because when it's turning, it comes back and creates some slack, and it collided with this wheel actually a couple times. So a little more tension on those 2 front wheels, and otherwise, boy, it worked great. Nice and fast compared to the Stug for sure. So that's a lot of fun. Do some more testing now that I got the track tension sorted out a little bit better.